Yes, very good evening to everyone. Welcome back. So I think most of you know me. So we are taking biostats module. So just want to know that you all are PG diploma in clinical research, right?
Yes,
Yes,
ma'am.
ma'am.
Yes, okay, okay. So we are learning biostats module. Now the importance of biostats in clinical research is also very much important. So guys, in any research, not only in clinical research, yes, thank you guys for responding. So not only in this research, anywhere you conduct research, you should have some knowledge about statistics with respect to how to interpret the data, how to write the results and report. So whenever the statistician will give you some test, I mean, a statistician will definitely will give you some tables. So whenever the statistician will give you some test results and the tables, then you are supposed to know how to understand that table, how to read, how to interpret the answer, all that. So for that purpose, we are learning biostats. It's very, very important. So now we will be learning what is biostats and from where it all started and why it is important, biostatistics, why it is important. So what is statistics in general? We have statistics in every field. We have in MBA marketing, we have MBA finance, we have in data science, every field there is statistics in arts, management, commerce, everywhere. So in marketing industry, everywhere. So statistics is usually it's a science of how you collect the data with respect to research in any field. How do you present the data on a report? So you are collecting a data on 4,000, 5,000 samples. So when somebody will ask you, can you tell me how many of them are males and females? So blindly you give them just a table, that is the what do you call you're giving them only the what do you call this one Excel file, and you say you go and see how many of them are male and female. That is wrong. You cannot give your raw data to someone. You have to convert that data into a presentable format, like a pie graph or a column or a column graph, something like that. That is you listing some figures. So you need statistics, you need to calculate, you have to reduce the data. Statistics is nothing but reduction, data reduction step. So you are reducing the entire 4,000, 5,000 sample data in a more presentable format. You're telling overall how many males are there, percentage, 60% males, 40% female. This 60-40% is nothing but statistics. So like that, how the drug is showing efficacy and safety. Go and see the Excel file, you can't say. You can't say, come and see the clinical trial, you will know how the people are performing better. No, it's not like that. You collect some data, you do some test, statistical test, and that will tell you whether your drug is showing efficacy and safety. That is called analysis and interpretation. So the definition of statistics is nothing but collecting the data, presenting the data, analysis of the data, and interpreting the data. So today we are learning some introduction of statistics, but however, it is really very interesting, and some facts we will know why statistics department is very important. Why we need to do statistics, so that we'll be learning today. So that is with respect to statistics. Now coming to biostatistics. Biostatistics means the same thing. You're collecting the data, organizing, analysis, and interpreting the data, but the data with respect to living organisms. Living organisms can be humans, can be microbes, can be animals, anything. So you're collecting the data with respect to the that is in health sciences, and you're drawing meaningful conclusion, and you're making informed decision. So you are doing some data and you are implementing something. So most of the health policies in the government or in any country are based on statistics only. So have you seen any parliament sessions? It's always sometimes if I'm too much stressed, sometimes I just open up a parliament session. Sometimes it is informative, at the same time it is entertaining as well. So many people, they defend themselves by showing statistics of the programs that they have implemented. I have implemented this policy, and with this much percentage of the people have registered, this much percentage of the people have shown outcome, improved status, like that. How do you prove that your policy is working? And what is the problem in the society? That is why I'm implementing this policy. I'm giving this much funds and this much money I'm allocating for this particular sector, is because of statistics only. So like that, drugs approval and anything, you need statistics to prove that the drug is really working or not. You need statistics to prove that there is some conclusion, meaningful conclusion you have to withdraw. Like for example, hydrochloroquine is a very good drug used for malaria. But now recently they got to know a lot of data on hydrochloroquine, that quinine drugs or quinine, anything from quinine source, the drugs are showing a lot of toxicity in different organs. So that is through statistics they proved. Otherwise, you can't blame a drug just like that. You need statistics. So statistics is like proving true or false. You collected the data, but how do you prove that the data is showing a particular statement? It is, you can prove a statement or not. So in upcoming classes, we're gonna learn all these aspects of statistics. So mainly it is used for analysis of the data from an experiment. Okay, to understand your data. Collecting the data is not, doing the experiment, collecting data, conducting research is not enough. How do you do perform analysis for that? That is more important. Then how do you interpret? Interpret means you did some test, but what you understood from that test, how do you draw the conclusions? How the data is distributed, sample size calculations, you need to know how the sample size is calculated. Test of significance. What is significance? Significance is like, for example, I say drug A is showing improvement in an effect. Let us say cholesterol. Drug A is showing the outcome. It is lowering the blood cholesterol. So lowering cholesterol by 2 units, 3 units, 1 unit, okay. But how significant it is? Significant means there should be a difference, very huge difference. Earlier, the cholesterol levels was 300, and there is a marked decrease in the cholesterol levels by 20 units. That is called, a very marked difference. Okay, that is one meaning of significance. Other meaning is you're collecting the data on 5,000 people. In that, how many of them, suppose, let me just write on the screen. Okay, let me just type on the screen. You're doing a research on 5,000 samples. Okay, and you're doing only before and after, before and after study. So I think you all have learned in CR module. I told you before and after type of trial is called uncontrolled trial, where you don't have a control group. Okay, you just have an experimental group. It's an uncontrolled trial. So you are taking 5,000 people. Before giving the medicine, you're checking their cholesterol levels. So like this, you will have person 2, person 3, person 4, person 5, like this. So before, maybe this person is having 320 mg per dl, for example. I'm just writing the numbers. And after it is 300. And here this person has again 350. And after the person is having 348, and then next person is having let us say 250, and here he had only 240, and this person had the cholesterol 299, and he got reduced to 250, and then this person is having 256, and he had the cholesterol to 256 again. So like that, you will be collecting data on 5,000 people. So if you carefully observe this data over here, where should I place this sheet? Okay, I'll keep it here only. If you carefully observe this data here, first person is having very huge difference. 20 units is reducing cholesterol. Second person only 2 units. Third person only 10 units. Fourth person maybe 40 units. Fifth person there is no change. So like that you are repeating for 5,000 people. How can you actually tell how many number of people have reduced? You can't do overall average. You can't take out mean of this. You can't do like this. On an average, you can't say this much was the total reduction. No. So here this person has reduced significantly. This person did not reduce, no significant difference. Okay. I'm writing short form, significant. This person also there is no, okay, we can say to some extent, uh, slightly significant, slightly significant. And this person is showing some significant difference. This person is showing no difference at all, no significant difference at all. Significant means a huge difference. So, like this, you're repeating for 5,000 people. So, how do you actually say that your drug is showing it is lowering cholesterol? Okay, I agree. But is it lowering significantly or not? Okay, are you understanding the difference between significance? Lowering cholesterol just like that, yeah, it will do the job. So every day I'm taking it, okay, it is lowering my cholesterol, but I need some change in my blood parameters. There should be a significant difference, right? So like that, how significantly it does the job? How do I do that analysis? So that is called test of significance. So there are certain parametric tests like T test, Z test, chi-square test, ANOVA test to find out the test of significance. So like that, these are your statistics and these are your statistical tests that you are supposed to do. So like that, this you will use statistics to find out whether your drug is showing a significant difference or not. Showing the differences does not matter whether the drug is showing efficacy. Okay, effectiveness I want potency, I want effectiveness, I want potency. So that is called that you can prove that your drug is showing significant result only using by statistics. So like that, data reduction and regression analysis. Data reduction means like, a huge 5,000 sample. How many of them are male, female? How many of them have shown significant result? How many of them have not shown? So a huge 5,000 rows are reduced into only 4 to 5 rows of data like that. That is called data reduction and you're showing the report. And then regression analysis. Regression analysis means there's so many factors. Yes, Dr. Kausik, you have a doubt?
Ma'am, in the significance, if it is a we are taking for 5,000 people,
Hmm.
so the majority of the people, if they got slightly difference, that comes under significance, or
No, no, no. For test of
we should also see
significance,
the
no.
things like
No, no. For the test of
yes, ma'am.
significance, Dr. Kaushik, we perform certain tests like in statistics. We'll be learning in upcoming classes, but let me give you an overview. There are for different
Okay.
kinds of data, different kinds based on your objective. There is something called T test. In that T test, you have again one sample, two sample like that. Then you have chi-square test. Then you have chi-square. One second. Chi-square test, then you have ANOVA test. Like that, you have different kinds of tests for parametric, I mean qualitative, quantitative, that we'll be learning in upcoming slides. But the end goal of all the tests is there will be a p value. P value is called probability value. P means probability. So p value less than 0.05 means there is a significant difference. In the statistical test, the statistical software will give you a p value. So suppose you got the p value 0.01. Okay, 0.01. So it is less than 0.05, right? So 0.05 means 5%. 5%. And similarly, p value will be 0.01 also, level of significance 0.01. So this is equal to 1%. Okay. Similarly, p value will also be 0.10. This is called 10%. Now I'll tell you what is 5%, 1%, 10%. This will be learning ahead. So 5%, if I test my data, 5,000 sample, and I got in my statistical test, I got p value less than this value. Uh, I'll say my data is statistically, there is a significant difference before and after. So it means my drug has showed some difference than existing value, and that's how it is called a significant difference. I just upload all my 5,000 sample before and after into the statistical tool, and the tool will give me a test value like this. So if my value is less than 0.05, or my value is less than 0.01, my value is less than 0.10. If it is less than 0.01, how can you say less than 0.01? You will get like this 0001, like this. If you get this as a result, you will say 1% significance, 5% significance, 10% significance. Now, what is this 5%, 1% significance? There might be 5% of chances that my data is not showing a significant result. 95% my data is showing a significant result. Are you understanding? Similarly, 1% means 99% my data is showing a significant result, and only 1% there is a probability that it 1% of the entire sample might not show a significant result. Like that, 10% means 90% of my data is showing significant result, and 10% of my entire sample might not show a significant results. So like I showed you just now, 5 samples I have shown you the example. So this statistical tool will see the level of significance among the entire data, and it will tell you whether your data is showing at 5%, 1%, or 10%. There are sometimes certain tests will not show any significant difference at any level. That time you will say it is not statistically different. There is no statistical significant difference. So this is where you use clinical SAS or R language, R program, or you have SPSS software, or you have Strata softwares. All these are paid tools. So the statistician will you will just give the raw data. They will input the data into the software, and the software will be doing the test. Now, in the upcoming classes, now you will say, I don't know to use this software. How will I do? In the upcoming classes, we are learning the formulas, how to calculate t-test value, and the software will calculate p-value, right? So how do I do it manually? So in manually, I have one more solution for all of you. Using some log tables, there are critical values. So if you want to calculate, so see all these softwares, Excel, computer has come now. What about in olden days? These things were not there. People used to use calculator and formula, and they used to compare with the critical values. So if the critical value is less than or greater than the log table, some log tables are there. So in upcoming classes, we'll be learning how to do these things manually. So most of the people, what they do, if they don't, because these statistical softwares are very expensive, very, very expensive. So if you are doing a master's program, or you're doing a project in your hospital or wherever you're working, you want to do a statistical analysis, you can input the formula into Excel. You can use that Excel for a huge data and simply apply into the formula and compare your value with the critical value to tell whether your test is significantly different or not. So is it clear? Did you get some idea, Dr. Kausik?
Yes, ma'am. Ma'am,
So
if
this,
we take the samples, there will be age difference and the gender difference.
Yes, yes, they will be everything. They will be all these things. Age difference would be there, gender difference would be there. So considering all these, the software will give you the what you call results. So usually we will check before we perform statistical test in coming classes. We're gonna learn about normal distribution. So like you said, age difference. If there is a too much of difference in your sample, that sample is not normal. I will call your data is abnormal data, right? Because so many different variation you have. So if your data is not normally distributed, you will, for normal distribution, you go for parametric test usually. There are some kinds of parametric tests that we'll be learning. And for some kind of data, you will not get normal distribution curve. Okay, you will not get. So where that normal distribution is not there, that time you go for non-parametric test like that. So like for psychosocial test, most for psychology or psychiatric for rating test where it is with mental health. Why? Because for psychological well-being, see, if I have to measure your blood glucose values, I can measure using blood test. But if I have to do quality of life trial, if I want to improve the level of suffering in your life, I want to improve that, decrease the pain level due to headache or migraine or happiness or mental well-being. For that kind of most of such data is non-parametric. I can't say how happy you are. If I ask you to rate your happiness in 1, 2, 3, 4, 5, you yourself can't judge which ranking should you give, right? So such kind of data is not normally distributed. So like that, these concepts, like in upcoming classes, we're gonna learn about this thing, normal distribution and not normal distribution. What are the tests for normal and not normal distribution that we'll be learning. So few important tests with respect to clinical trial and RCTs we are learning here. In detail, statistics is a very big thing. It's you have an entire 3-year program for that you can go more. If you're interested, you can go more in deeper there. However, here with respect to clinical trials for RCTs, before and after type of studies, and for comparison of two different drugs or two different samples, what tests to be done, because most of the RCTs are parametric tests. You can measure. Parametric means you can measure it can be measured, and you have a absolute value. It is not something like rating scale and all. So like that. So that we'll be learning in upcoming classes. So we'll be learning everything here. That will be in the third week or fourth week, guys. Okay. So initially we should learn some basic terminologies and all. Basic test, how to, like I said, data reduction. Suppose Dr. Kaushik was telling age. If I want to know what is the average age of my sample of 5,000, if I say, what is the age group of your people? You will say, we have people from 20 to 25, we have people from 25 to 30, we also have from 50 to 60. How do I understand actually? I want what is the average age of your entire sample, mean, and standard deviation. So, standard deviation means what is the minimum and maximum value, and how many people, how much variation is there in your data. That is called deviation. So, like that, we're gonna learn first descriptive statistics. We will learn. Descriptive means how you describe your data in very simple tables. How do you describe the data using graphs like pie graph, column graph, all that we'll be learning that. And then later we will be learning inferential statistics. Inferential means you have two factors. You want to see whether your drug is working or not. That is test of significance. Test of significance are all inferential. You want to draw some conclusion. You want to prove a statement. This drug is showing efficacy. For that, you use test of significance. So that will be learning in upcoming classes. So mainly in third and fourth week, first 2 weeks are basics, and we'll start with descriptive statistics and different important concepts. So without learning those concepts, we cannot understand most critical concepts. So that we'll be learning here. So, like that, statistics is used for comparison of performance of drugs in clinical trials. The info data that how the people will forecast the weather. Tomorrow there'll be heavy thunders or day after. How exactly they can say this? Because of statistics only, using statistical formula and all. Accidents between cities is happening because of overspeeding or because of some other reason. It is through statistics only you can give a theory. You can't give just like that. So, like that, statistics is more important to show or prove any theory. So, statistics have a lot of applications in biomedical research, pharmacy, public health science, agriculture, fishery, ecology, system biology for gene network inference, and pathways analysis. What are pathways analysis? Like metabolic reactions or like metabolomics, proteomics, gene network inference. What are the genetic parameters that are affected by a particular drug or particular disease? What are the change in the different genetic markers? Which are the common genetic markers observed in all the diabetes individuals? Statistically, they will try to find out. Like that, statistics is used in everything, population genetics, like that. So now we will learn some important things, how statistics have originated. Only few instances, like in 1929 there was a huge paper on application of statistics published in physiology journal by a person done. Similarly, in 1937 15 articles on statistical methods were given by Austin Bradford Hill. He's a very famous researcher. He published a book, How Statistics Are Important to Prove a Concept. Like that, in 1948, RCT on streptomycin for pulmonary tuberculosis was published again by Bradford Hill. So there is a university by his name also, I think. Bradford Hill, there's a university by his name. So like that, growth of statistics has increased from 1952 to 1982. And now without statistics, there is no uh, drug approval or anything. So these are famous statisticians who has given, like Carl Pearson correlation coefficient, how to perform R test, how to perform chi square. I was telling about certain tests, no? These are the famous people who has given these formulas and Gaussian's distribution, normal distribution and all that was given by these famous people who says if you have these concepts only go ahead for this kind of test, like that. So now, like Dr. Kaushik also was telling, there's a lot of variation in age and gender. So let us understand how these factors are important, why we are using statistics, because there's a lot of variation in data. So there are so many medical uncertainties in any research, like intrinsic factors due to biological, environmental, and sampling factors. We'll understand this. Each of this we will learn now. Natural variation between different researchers, how they perform the research, how they observe the data. Instruments. One person will use very good instrument from one country, like that. There are errors in measurement. Some people might not have good methodology practices, errors in knowledge, incomplete knowledge. Let us understand each of these things. So, intrinsic variations, like Dr. Kausik was telling, biological variations due to age. Everybody's age, influence of drug is different based on age. Influence of drug is different based on gender, heredity, parities, height, weight, everything. So there's lot of variation in every person, anatomical, physiological, and biochemical parameters. With respect to location also, people in Western countries, their metabolism is different, and people in Eastern countries, their metabolism is different because of climatic variations. The BMR metabolic rate is different, how drug interact. So how do I prove that the drug will really work when there are so many variations? By using statistics. These eminent researchers have given the formulas. We can't doubt their theory. So they have given the formulas for this kind of data, what test should be applied, like that. So lot of environmental factors are also different, like due to nutrition, what food they are consuming, smoking. Now you can't, while doing the trial, clinical trial, it's a controlled experiment. But when your drug is in the market, you can't hide the fact of smoking, pollution, facilities of water, sanitation, road traffic, legislation, prices of the drugs, stress and strains of the people. And everything has a difference. Like for example, you must have noticed, guys. Suppose it happens with me actually. I am taking a very good branded drug whenever I get any infection, cold, cough, or fever. But unless and until I am on leave and I take rest, I am not recovering. If I'm taking medicines and I'm on work on duty, even though it's just just I'm not sleeping, I'm just awake. Still, that drug will not show full efficacy. Lot of stress, metabolic stress, physiological stress also has effect on the drug. So like that, all these factors are there. So how do I eliminate the factors? To eliminate the factors, there is something called regression analysis. So like that, there's so many things that are given. So sampling fluctuations can be there between the sample size. Entire world cannot be studied, right? We are studying only in India or only in Asia, wherever you are there. So, how certain cases cannot be never included in your trial, like geriatric population, pregnancy women, people with HIV, cancer, like that, when you're doing a trial. So, a lot of fluctuations are there. Chance variation due to unknown or complex factors. Chance variation. What is a chance variation? Because of certain factors during the study, maybe the facilities available at the site or anything, there can be a change in the variation of how you are collecting the data. Unknown reasons or some your personal reasons, because you don't have sufficient knowledge and practice how to collect the data, then there might be a variation. So many variations are there that might lead to medical uncertainties. Uncertainties means the data might have errors, right? Then natural variations also are there despite best care as a source of uncertainties. Okay, even though I do a lot of training experience, sometimes in assessment of any medical parameter, like while taking blood pressure, somebody is having visual defects. Earlier, we used to have, now we have digital machines, but earlier, people have to see that mercury bar meter to record the blood pressure. So, visual defects might be there, partial compliance with the by the patients. You said the patient consume the drug immediately after you take food, but the patient has consumed the drug after or before the food, or maybe on a oily food, something like that. The patient is not showing compliance. Then there is change in the parameter due to incomplete information in conditions such as patient in coma. Sometimes, if the patient is in coma, you don't know complete data on adverse event or anything, what has happened, like that. So, what will happen? Your data will have errors. So, such errors are called outliers. So, statistics has the solution for that also. How do you detect an outlier? Outlier means extreme values, or whether the data is showing significant result or not. If the data is not showing significant result, sometimes your research wants. Now, for example, guys, I'll tell you two types of scenario. I'll take some time. I'll tell you here. If I am doing before and after trial, okay, then I want a significant result. Means difference. I want a difference between both the data. Before and after, I want some change. But if I'm doing a generic drug, let us say, I am collecting the data on bioavailability, bioequivalence, and using animal studies. Okay, I need not do clinical trials for generic drug. Okay, so I am taking 20 mice and I have collected the data. So I am comparing a drug A and a drug B. Now, what is generic drug? Generic drug means both the drugs should show equivalence, therapeutic equivalence. Bioavailability also should be same, bioequivalence also should be same. So in this kind of statistical result, what is my objective? I should not get, I should get no difference. I should get no difference, or there should be no significant difference. Are you understanding, guys? Certain tests I might require significant difference based upon my objective. Now my objective is a generic drug. What is my objective? Both the groups should not show any difference. Both of them should show almost similar results of therapeutic bioavailability and bioequivalence. So like that, certain objectives require significant difference. So what I want to prove here by this explanation, always having significant difference is not the aim of any statistics. Statistics is to prove a hypothesis. Hypothesis means a statement, an assumption. So in case of generic drug, my hypothesis assumption is my drug A is equal to drug B. There is no significant difference. I want to prove that statement. So using statistics, if I get p value above 0.05, then I will say, yes, it's very good, there is no difference. And if my p value is less than 0.05, then I'll say, uh, oh, my generic drug is not showing same equivalence with respect to the same drug. Like that. Similarly, if I compare drug A with the gold standard drug, gold standard, okay, that time I want significance. I want significant result, and I want a significant, I'm writing short form, okay, significant difference. Understood, guys? So the test you're using statistics, like what is a calculator? A normal calculator. Just like that, statistics is a tool, it's an application of a science and knowledge to prove a statement. What is your statement? Based upon your statement, you should do interpretation. That's where. Okay, guys, any doubts here, everybody? Did you understand? So, through statistics, we will also encounter all these variations and problems in anything while we are doing research. Medical errors also might cause uncertainties, like carelessness of the providers, such as physicians, surgeons, nursing staff, radiographers, pharmacists, how they are providing the drugs, how they are handling the drugs, errors in the methods like issuing incorrect quantity of the drug or quality of the chemicals, reagents while doing the manufacturing of the drug, misinterpretation of ECG report, or inappropriate diagnostic tools or very faulty tools, misrecording information. Like recently, one of the case I have seen. Today, the hemoglobin concentration of a person was 10, okay, 10 gram per DL. And tomorrow we did the hemoglobin estimation. Suddenly it has become 6. I was like 10 and 6, how come 4-point reduction in one day? It's very difficult. So there was an error. Then we repeated the test again. And then we got the value again somewhere near 9 and 8. I mean, 9 only we got, 9 or 10, not even 8. So this was a misrecording of information. The way the person has taken the blood sample, he did not dilute the, he did not shake the, what do you call, sample properly while doing estimation. He took only the serum and he did the estimation like that. So that way there can be instrument error, there can be non-standard instruments, not collecting full information, a lot of inconsistent response by the patients. All that might give certain uncertainties. So all that is why we need statistics really to show the significant difference. We can't say by physicians or investigators' decision, yes, yes, drug is working. We saw many patients showed improvement. They're very happy. Very good drug is very nice. No, that is wrong. Collect the data and show through calculator. Statistics is a calculator. Show through calculator there is a total difference or not. It is just like telling I have a lot of money. No, don't tell me such statement. Show me your bank balance, I'll tell. Show me the bank balance, then I will prove that, I will believe that yes, you really have a lot of money. So like that, statistics also, just by telling, by giving some statements or reports, a lot of uncertainties in the knowledge of the people, reports, and a lot of uncertainty in survival duration of the patient. Some people will die very earlier, especially in oncology trials, like that. A lot of uncertainties are there. How to measure positive health also, like I said, rating scale. So for in order to prove that non-parametric values, you need statistics. So biostatistics is a science that helps in managing all the medical uncertainties. Knowledge is different, instruments are different. How can you say tumor size has reduced? It's not about the size reduction. The size reduction can be reduction in the inflammation, not in the tumor cells. You see the blood profile, you see how many cancer cells are there in the blood. You see the what you call different tests and try to find out. So biostatistics will tell you how to manage those medical uncertainties. Okay. So like that, reasons you need to know about biostatistics is medicine is becoming more quantitative in nature, and how you are planning research, how you're conducting research, interpretation of that research is completely reliant on statistical methods. And statistics pervades medical literature. Okay. So, guys, we are learning different concepts of statistics, true, but unless and until you're a true statistician, that is, you have done MSc statistics, or you have a certification in using SPSS or SAS or R programming, you can't do a statistic result. In research, statistics should be performed by the statistician only. And we are learning statistics. Why? Because they will give us the report, but how to understand that result, how to write discussion, results, conclusion, how to understand whether the drug is showing efficacy or not, what is t test, chi square, why they have done that test. You should be knowing that. In order to write the medical report, in order to explain to some person, in order to communicate with someone. That is why everybody should have the knowledge of biostatistics as well. So, like that, a lot of clinical medicine is used in biostatistics is used in that field. Documentation of medical history of diseases, planning and conduct of the clinical studies, evaluating the merits of different procedures, methods, that define normal data or abnormal data. You are using statistics for all these concepts, like that. So in patient care also we are using statistics like regarding diagnostic devices, therapeutic and prognostic uncertainties. What is prognostic uncertainties? Prognosis. How long the person will survive, for how many years? What is the disease prognosis? This treatment regimen will make the increase the chances of survival by 5 years, 3 years. How do you do? How can you say exactly? Through statistics, like that. So it gives us the chances to value judgments to be more beneficial to the patient. Earlier, HCQ was used only treatment for malaria, but now you have advanced drugs and they are telling don't use hydrochloroquine now for malaria. It is having a lot of toxicity. So they have made value-based judgments based on statistics. It gives us a lot of sensitivity and specificity and predictivities methods. Means whether the drug is sensitive, whether the drug can diagnose a disease or drug can cure a disease. We can predict how the drug will work in future, like that. By performing valid tests for patient assessment, we can use statistics. So it gives us the tools such as scoring system, and it's an expert system to reduce epistemic uncertainties. Epistemic means something that has a lot of uncertainties since the beginning of the trial. Lot of problems are there in the research and lot of uncertainties are there right from the beginning. So it gives us a scoring system, scoring methodology like t-test and critical values test to understand really should we accept a theory or not, like that. So example, guys, recently, um, I gave this example long back. I don't know, you know this example. uh, American Cancer Association, they have given a statement. They have done observational studies and they performed statistical analysis for observational studies. And they got to know that intermittent fasting is leading a lot of cardiac events are there if you do intermittent fasting. Whereas clinical trials were not conducted for intermittent fasting, but some of them have done small clinical experiments. They have done, and they showed that intermittent fasting is beneficial. So, like that, how you prove a theory, whether something is good or bad, is through statistics only you can prove the theory. So that is the role of statistics, guys. So any doubts, everybody, this is just the introductory class, and we'll be learning some more concepts about statistics tomorrow, how statistics can be important. Okay. Yeah. Yes. So, Jude is asking me a question, whether intermittent fasting is bad for health or not. As such, we don't have very good clinical trials for intermittent fasting. Nobody has done a huge trial like 4,000, 5,000 sample. Some of them, they have done some small trials where they saw some reduction in the weight loss and some improvement in clinical parameters. But let me tell you, weight loss is not called being healthy. Nobody has done clinical trial to see how this intermittent fasting will have ill effects, like toxic effects. It might have toxic effects, like malnutrition because of fasting can lead to type 2 diabetes or type 1 diabetes, malnutrition related diabetes. If you do a lot of fasting, is your immune system being affected? And is your immunity function as reduced? Nobody has studied the effect of intermittent fasting on immune function and immune related cells. I mean, like, B cells and different types of cells and different types of inflammatory markers. They have not withdrawn the samples of inflammatory markers and they did not see is there any change in those parameters. Everybody studied intermittent fasting, weight loss. That's all. And intermittent fasting, diabetes control. So, but nobody has seen the long term effects of intermittent fasting. So, like that. Yes. So, Lakshmi Shankar is asking me the study material for biostats. Okay. So, I'll be uploading the study material for biostats on the LMS. I'll ask Manish actually to upload, give the access because he's having the right material. What I'm teaching you all is a little bit additional content, and I'll be uploading the PowerPoint slides at the end of the module, guys, the entire PowerPoint slide, all, because I'm adding few more slides as in I teach you all based upon the level of understanding. So that way. Okay, so PowerPoint I'll be uploading for sure. Study material will be there. Manish will be uploading that in the LMS. Okay. Yeah. So that is it about with respect to that. So any doubts, everyone? So, as such, somebody was asking about intermittent fasting. So, a lot of observational studies was done by American Heart Association. But if you see the significance, clinical trials, usually we can say we can prove a theory. Observation studies is not experiment, right? It though we can make a theory out of observational studies, we cannot believe completely, but clinical trials are needed in that area. Yes, you have one more question, Jude.
Ma'am, I asked that question because I seen a lot of YouTube videos, especially in doctors. They are saying that some significant importance or benefits of having intermittent fasting in once a week at least. So that's why I ask you that question: is
Great,
intermittent
great.
fasting? And
Yes,
ma'am, you are telling that we don't have any trial related proof that intermittent fasting is good for health. Is it?
yes, yes. There are so many trials that are showing weight loss and good control on sugar and blood glucose, cholesterol levels, but long-term effects, nobody has done a longitudinal study. I mean, how it affects your liver, kidneys, and other body organs and immune system, all that they have not done. So if I say good, good means something means that should not affect your health ultimately. You're doing fasting for weight loss, but you are losing your immunity and you're getting TB later. They have not studied such things like how we do in drugs, post marketing surveillance. Like after the drug is launched into the market, we do for 5-10 years, we follow them up. That is called cohort study. Nobody has done cohort study. You know, you did intermittent fasting for 12 weeks, you're showing the result. 12 weeks results is shown, 6 months result is shown. But did you follow that people for the next 1-2 years? What has happened to them? Did they double the weight? Did they what has happened to that? Did they have any cardiac events? That is not there in the research. So like that, many doctors, they have uploaded a lot of videos, and when this American Heart Association has given this news, no, a lot of debate went on online, and a lot of researchers and scientists had a lot of debate, and because many people now they have given these videos, no, and suddenly American Heart Association has given a statement. So a lot of people, they will lose their what do you call trust factor among their followers, that suddenly Heart Association said this and you are telling us to follow intermittent fasting in your videos. So like that, a lot of debate has sparked online, but we have to follow always the evidence based research. Evidence means a lot of clinical trials is needed. Like, you know, many people, a lot of things are there. I myself, I'm a health practitioner. Like, I'm basically into diet and nutrition and all that. So what I feel, every body is different. You know your body very well. How is your BMR, metabolism? If you are having gastritis or acidic reflux for every 2 hours, it means you have a high metabolism, high BMR, and you cannot go for intermittent fasting like that. So the different types in fasting, it's not pure fasting. You can take fruits, you can take fluids, but not carbs. That kind of fasting is okay, and only for 4-5 hours you can do. But if your body is showing you signs and symptoms that no, you're becoming weak, you're having constipation, you're not having enough stamina, you're having weight loss, but later after 2-3 weeks you're falling sick, then it's not the right thing for you. So I have seen a lot of people, you know, although the research has not been done, because we can't force somebody to do intermittent fasting. It is unethical actually. 12 weeks is okay, but 6 months or 1 year, you have not done the trial, and you can't prove really it is safe or not. Safety comes where when that does not affect your metabolic circadian rhythm also. Like how you have a circadian rhythm, you have a metabolic rhythm. Your cells are used to function, glycolysis, Krebs cycle, enzyme, all this release based upon what you eat, what you consume. And if you're disturbing that cycle, what will happen to your body later? So I have seen many people who fast, no, alternate days, who fast in a day, they take only one meal. Some people, the body tolerate well and they are very healthy. Okay, like certain celebrities, because their job is just to hit the gym and then do it. But the people who are working a full-time work like 9 to 5 job, there's a lot of physiological stress that they go through, physical stress. Their brain requires a lot of carbs, a lot of glucose to work. So such people are different, and such people are doing fasting, they are ending up in diabetes because it's malnutrition related. Because you all know, all hormones, enzymes are protein in nature. And if you're fasting for a day, your thyroid hormone, your insulin, your enzymes, how are they released if you don't have protein intake for that day? Some people take a high protein diet, 25, 20, 30 eggs. Then they have a okay, good hormones and enzymes. But if you're going on fasting, your protein intake also comes down. Then what about your enzymes, hormones, your different neurotransmitters in your body? your different functions of your neurons, everything is protein in nature, right? You all agree? Every cell tissue healing, you get an injury, then tissue healing is everything is in protein in nature. But those clotting factors, everything is protein. So if you don't have these things, your metabolism is disturbed, and thereby you are making a lot of changes. And that way, somewhere after maybe 1 6 months or something, you will show some ill effects of fasting. So really, it is not proven. So until it is proven, nobody should advocate. That is what I feel. You have to find which is best for your body. So if you consider my case, no, I'll tell you genuinely, I cannot stay without consuming any food for 2 hours, more than 2 hours. I need to consume something within 2 hours. If I don't consume, I get acidic feeling, and I get a green color vomiting. How do I do fasting then? And my body weight is normal, and I am not overweight or obese, but I eat all healthy. And at one time, I can't eat more than 100 grams of anything. Let it be rice or let it be anything. So my food intake is very less because I can't eat more than that much amount. If I eat, I get what do you call SOB. SOB means shortness of breath. I can't breathe properly. I feel very healthy. My stomach is completely packed, then I can't breathe. I'll get vomiting if I overeat. So my food intake is less, thereby I need to consume for every 2 hours. So everybody's body is different. So that advocating, it is like, same goes with the drug. You get throat infection, take 500 mg antibiotic. You all, some other, your parents also are getting infection, take 500 mg antibiotic. Irrespective of measuring what is the infection rate, you're not measuring what is. So everybody's body is different. One size cannot fit for all. That is what goes with the fasting also. It is not same for everybody. You have to know which is correct for your body, like that. So that is why I don't advocate. I will try to understand the lifestyle of a person, and whether it is suitable or not, you can then you can decide to follow or not. Yeah. So yes. So any more questions? Like, is it? Yeah. Yes, yes. Thank you, Jude, for asking that question and making an interactive session. Yes, long-term effects and results we have to see. That is what I also believe. Yeah. Okay, guys. Then I'll end up this session. I'll see you all tomorrow. Thank you, everybody, for your patient listening and making an interactive session. Thank you, everyone. Yeah. Good night, everyone. Yeah. Yes. Thank you.